What an exciting day, especially for you, I'm sure, being so involved in this Mars exploration. Tell us, first of all, kind of generically, what's been your involvement in these Mars missions up to this point?
Okay. In 1970, my wife and I moved down to Hampton, Virginia, to work on the Viking project, which was assigned to NASA Langley Research Center. Viking in 1976 put two orbiters around Mars, and on radio command from Earth, each orbiter released a package, and in the package was a lander. And both orbiters and both landers were 100% successful, and it was the first successful soft landing on the surface of Mars. Now, what's very interesting is that the technology developed for Viking in the early 70s is basically the same technology being used today for Mars 2020 rover Perseverance. We have a supersonic parachute that will open up, a 70-foot parachute. It will slow down the spacecraft that comes into Mars at about 12,000 miles per hour. And in 7 minutes, it has to land, and it lands between 1 and 2 miles an hour. That 7 minutes is called 7 minutes of terror because the spacecraft has to go from 12,000 miles an hour down to 1 or 2 miles an hour. There are probably well over 1,000 things that have to work at the precise time within a fraction of a second to be successful. And it is a unique procedure. And the United States is the only country in the world that successfully soft landed on the surface of Mars. We've probably had 30 attempts by 5 different countries, and only the United States has been successful. And the first two successes were in 1976 by the scientists and engineers at the Langley Research Center in Hampton.
Yeah, fascinating. It is just so cool. Tell us a little bit. So I understand for Perseverance, you were involved in selecting a lot of the instruments for the scientific payload. Is that right? Tell us about that.
Yes, well, one of my last assignments at NASA before my retirement was to be the program scientist at NASA headquarters for Mars Scout missions. These are missions that go to Mars. After I retired, I continued my work with NASA as a consultant, and in 2014, I was asked to serve on the committee that selected the instruments that will land on Mars later today. There were probably over 50 experiments and instruments, and we had to pick like the top 12 or 13. We spent about 3 months. There were about 100 scientists and engineers working 3 months to select what instruments and experiments should go to Mars. And there's some very, very interesting instruments. The instruments will tell us whether there is any evidence for life on Mars in the past or in the present. And one of the fundamental questions in all science is there life outside the Earth? So far, we know there's only one object in the solar system, one object in our galaxy that has living systems. That's the third planet from the sun, planet Earth. And we're very interested to know whether life is widespread in the solar system, in the galaxy, and beyond. And this mission today will provide a lot of information to tell us about the likelihood of life presently or in the past on Mars.
Man, this is just such cool things. I know one of the most recent out of this world experiences that you've been working on has been lunar dust and the impact that that will have on robotic and future human space exploration. Tell us a little bit about how that all came to be and what the implications are there.
Okay, about 2 years ago, NASA asked me to organize and chair a workshop with the title, The Impact of Dust on the Moon on Human Exploration. And that came about because we have a new program called Project Artemis. Artemis is a return to the moon with humans. The first human mission back to the moon will be in 2024. And what the Apollo astronauts noticed, we had the Apollo missions from 1969 to 1972. The Neil Armstrong and Buzz Aldrin on their first mission, first human landing on the moon in 1969, July 20th, noticed that the moon is covered with several inches of very fine dust, almost microscopic. And this dust is like glass. It's very, very sharp. It's very, very small. And what we found on Apollo 11 and all these subsequent human missions to Mars is that this glass gets in everywhere. It gets into spacesuits. It causes erosion of seals. It got into the helmet. When the astronauts flew back to Earth, when they blasted off the surface of the moon and met the command module, which was orbiting the moon and headed back to Earth, tremendous amounts of dust that were brought in to the capsule inadvertently caused so much difficulty. You could actually see it floating in the spacecraft. It affected systems on the command module. Now that NASA and the United States has committed to renewed program of human exploration on the moon, NASA was concerned, what do we do about the dust? So we had a conference. It was actually 1 year ago in February 2020 at the Johnson Space Center in Houston. That's where the astronauts are. And I had a number of William and Mary students participate and in fact present papers. And we examined the dust problem. What did the Apollo astronauts tell us about the dust? And how can we make sure that when the Artemis astronauts get to the moon beginning in 2024, they don't have these problems? And what's interesting is that the book summarizing the meeting was just published last week.
Very good timing, right?
Yes.
So you mentioned it there at the end of that bit, but I'd be curious, broadly speaking, what role have your students at William and Mary played in a lot of the NASA work so far and the missions to Mars and all of that? What role are you introducing these students to?
Well, that's a very good question. One of my last jobs at NASA was to chair a committee called Human Exploration of Mars Science Analysis Group, HEMSAG. Acronyms are very big in NASA. And one of our chores was to determine when humans go to Mars, which is scheduled for 2035, where should they land? Where should the first human mission to Mars land? And the HEMSAG committee identified 50 potential landing sites for scientific interest and because they look like it's safe terrain. And we published that list in 2010. Well, William and Mary, in the class on planetary geology that's taught by myself and Professor Chuck Bailey, assign a research project. 30% of the final grade is based on their independent work. And what they do is they draw out of a hat the one of the 50 proposed sites for landing on Mars, and they spend almost half the term doing a geological analysis of the terrain and where they should travel, what they should do, and so on. Now, the very first time we did that in 2013, I invited a number of scientists and engineers from the Viking project to come in the audience when the students gave their final talk. Each group had 15 minutes. And the NASA scientist, Gus DeFerro, who was the assistant project manager on Viking, his first comment was, I'm blown away by by what I heard over the last few hours. He said, you students know so much more about Mars and where to land than the Viking scientists and engineers did. Now it was 45 years ago. And we have a website, and each term we put on our website the results. Each student has up to 10 charts, and that's become a very interesting source of information for future reference on where we should land on Mars. In addition, now that I'm involved in Return to the Moon, one of my students is doing work on dust and how to reduce or mitigate the dust effects, and in fact, presented a paper at this NASA workshop last year. What was interesting is that the man who made the first measurements of dust to Mars, Brian O'Brien, at age 86, came to the meeting from Australia, where he now lives, and he presented a paper. He's the discoverer because his instruments that were brought to the moon provided all the data, and he's 86. And my student from William and Mary, Max Weinhold, is 19, and I took a picture of them at the meeting, the oldest and youngest. Unfortunately, Brian died a few months later, but we still have the picture. So what
Yeah.
we're trying to do at William and Mary is to get students, both undergraduate and graduate, that have an interest in planetary exploration, in NASA activities, give them an opportunity to do independent research. At William and Mary, you have to do a senior thesis. That's an important requirement for graduation. And I supervise senior thesis research for students. So we give William and Mary students an opportunity to get involved in a meaningful way with the US space program.
Yeah, it's fascinating, yeah, and I know that senior thesis well. Trust me.
Yeah, yes, I'm sure you do.
um, I could talk to you all day, but last question here that I have for you: when you watch today's landing, and having spent your entire career being involved in these types of missions, when you watch and you know what goes into getting Perseverance to the red planet, to Mars, how are you going to be feeling this afternoon during those 7 minutes of terror, and then just the sense of accomplishment? I must imagine seeing the limitless ability of the human imagination and what we are able to accomplish.
Well, I think the best emotion is one of being nervous because unfortunately, I know what has to happen precisely at the same time, at the correct time, and the order. And it's very nerve-wracking during the 7 minutes when this is happening. It's interesting. The last time we had a launch like this, I'm in a landing like this in 2013 for the sister mission, Mars Science Laboratory Curiosity. I happened to be in the control room at Jet Propulsion Laboratory, and I brought my son-in-law with me as a guest, and the director of Jet Propulsion Laboratory came in to the auditorium and happened to see me and came over to me and said, "So Joel, what do you think?" And I said, "Charlie, everything is going to be fine. Uh, everything will be fine. You've practiced this. We know what we're doing." And Charles Alachi, then director of JPL, said to me, "Joel, of all the people I asked, you said you're the only one who said 100% success." And he walked away. He said, "I hope you're right." My son-in-law said to me, "How come you tell me it's only 50% chance of working properly?" I said, "Because you're not the director of Jet Propulsion Laboratory, and he has so much on his mind." Later that evening at the victory party, about 2 hours later, Charles Alachi, the director of Jet Propulsion Laboratory, came over to me and said, "Joel, out of 100 people that I asked, you were the only one who said you're 100% sure it would be successful." And in fact, it was. And that's how I feel today. I think that we know what we're doing. We've done it before, and I think there's a high chance of it successfully landing and beginning a unique exploration in the history of the human species. On the other hand, There can always be something that we didn't think about or something that didn't work to the precision that it's supposed to. And but right now, I'm very optimistic that we'll all be celebrating later this afternoon.
Fascinating. Is there anything that I haven't asked you that you think is important that we include here?
Well, I just let me say that by supporting an active space program to explore Mars, to explore human exploration of the moon, the rest of the solar system, we are developing a very strong base for the next generation of scientists and engineers that have applications outside of the space program. So I think that NASA's budget is very small compared to the total federal budget, yet it has really triggered the imagination of the next generation of scientists and engineers. And I think that for the security and safety of our country in the future, we need engineers, we need scientists, and NASA and the space program is a very good way of bringing them into this field. And so I think that when we land on Mars, we're going to learn about Mars, but I think we're also preparing for the security and the future of the United States of America.
Well, thank you so much for your time.